All right, so exercise 1 is talking about that sampling distribution of a sample mean, and this does so in a way that I tend to like to put on an exam because, as you'll see, there are some potential traps for students. So in this particular example, we're given the population distribution, and it is a funky distribution. This is apparently for test scores. Did it say that? Yes, test scores. Doesn't say on what, but it's a funky test because we've got a multimodal distribution, right, with modes everywhere. You can maybe call that a mode, and this big empty spot in the middle kind of looks like one of our tests in our class, actually. Lots of people do really well, lots of people do really not so well, and there's very few people sitting in the C range. But they also gave us a bunch of information here at the top, the mean, median, and standard deviation, and you can see our mean ends up over here in no man's land. So what we're looking at for a bunch of graphs here at the bottom are possible distributions of our sample mean as we drew from this population. So what the question is here at the bottom is which graph represents sample means for 1,000 samples of size 4 and what about samples of size 50? So just quickly to break down what these different numbers mean. For the first sentence, this sample of size 4, this is our n, and the 1,000 is how many of these samples we're taking, what we would call replications. So you can imagine back when we did that smelling Parkinson's activity with joy, in that case we had 12 samples, right? We smelled 12 different shirts and decided whether we got them right or wrong, and then we repeated that 40 times for all the people in class. Then when I used StatCrunch, we did it like 1,000, 2,000 times because it was a lot quicker. So that's the idea. That's how many times we're going to do the experiment. But each time the experiment's going to have 4. So again, just to make this a little more tangible, let's say I went and took a sample of size 4 from this population. Let's pretend if I took a sample that maybe I get these sort of most likely things. Maybe I get like each of these modes, right? Because they are the most likely things. Say I even get that one. And then what I would do is I'd be taking the sample mean. So I had a 53, I had a 57, I'm just grabbing these numbers, I had a 64 and a 68. I'd be adding these all together and dividing by 4 to figure out what my mean is for my sample, which would be 60.5, right near our original mean, because basically we're averaging and we're finding the middle, the balancing point between all of these values. So it makes sense that we end up somewhere here. And we're not guaranteed to be at exactly 60.5. I just happen to choose our modes. It is possible, right, that I would get maybe more stuff over on the right, and then I would have a mean that's a little bit different. But this is what we're talking about. We're talking about the distribution of sample means. If I took a sample of size 4 and took their average and then popped that down on my little graph, what would that look like? So I want you to take a moment, see if your intuition is right, decide which graph represents doing this with a sample size of 4 and which one represents doing this with a sample size of 50. So in the sample size of 50, I'm going to be grabbing 50 of the observations and averaging them. All right, so hopefully you've finished this and you've made a guess, because like I said, making a guess makes it a little more tangible. I'm just going to describe what we see in each of these graphs. Graph C looks like the original graph, right? Very similar. It still goes from 50 all the way to 70. Still has sort of that same shape with that weird gap in the middle. It's just a little bit messier, right? There's more variability to it, but looks like the original graph. A looks like the original a bit, but it's obviously less spread out. We still see 1 mode, 2 mode, 3 mode. We still have that gap and all the different modes, but we've just taken it and sort of squished it in. B and D both have changed shape now. Both B and D have 1 mode in the middle, right? Both of these have become unimodal and are starting and trending towards symmetric. So turns out that B and D are our correct answers. B is going to be true for n of 4, And D is going to be true for our n of 50. And this is because exactly what we saw on the last page, right? As I start taking the averages, I'm going to fill in, and most things are going to be exactly what happened here, close to our real average. Just because there was a gap in our original distribution doesn't mean we're going to continue to see that gap when we're talking about sample means, because as I grab things from both sides, I'm going to fill in that gap. And in fact, most things are going to be right around the average that we expected for the population. So both of these are centered at that 60.5. It's just a matter of this one is, they're both centered at 60.5, but D is less spread out. Because as we grab more and more dice or more and more test scores out of here, it's harder and harder to get values in these areas, because that would require me grabbing 50-ish test scores that are in that area, right? As we're taking an average, it's harder and harder to get further away. Just to point out what graphs A and C are, C is actually just pulling a sample, right? And if you really wanted to think of it as sample means, it would be an n of 1. This would just be a sample of 1,000. No replications, no sample means. This would just be what happens if you take a sample from that population. You're going to hopefully get a distribution that looks like our population, right? A representative sample. But there's going to be some variability because of the randomness of sampling. And then A is bananas. All right, I have no idea what I said last. There was a cat fight outside, and my cat turns into a psychopath if she hears other cats, so I was running for cover. Anyways, graph A is bananas. That's, I believe, what I was saying. Bananas. There is absolutely no situation where we would get out something that looks like the original distribution just squished in like this. This is just playing on the idea that we know that our standard deviation is going to be smaller, and seeing if we can get students to bite on this. So A is just a wrong answer that has no correct situation whatsoever.